So once again, Dejan Zouari, Business Solution Manager within the Global Technology Practice, working out of the SAS office in the Netherlands.
Yeah.
The floor is yours.
All right, is the presentation set up? All right, good. So let's start this like we start every Skype conversation. Can you hear me well? Yeah, everybody, great. All right, so I guess I'm just waiting for the presentation. It's ready, okay. So I want to start today by talking about open ecosystems for AI. So I've broken it down into 4 different segments. So first, I want to make sure we're aligned on the definition of AI. Everybody sees it differently, whether they are movie theaters or companies, everybody sees it differently. So we need to align on how we see AI. I'm going to present it from the SAS point of view. Then we're going to discuss about open. What does an open ecosystem mean? And then going to present a little bit the SAS platform and finish off with some of the applications that we're working on. And with that, I'll start with the definition of AI. So basically, the key word here that needs to be defined is intelligence. How do you define intelligence? Where some guy tried in the 50s, he's Alan Turing, and he said that the AI is measured basically by the ability of a machine to trick a human into thinking that it's a machine. So the higher the probability of you tricking in a machine into thinking you're a human, that machine is actually thinking. So that is what we call the Turing Test. And there is a movie about it, which is the title of his paper, The Imitation Game. You can watch that. So this is his vision, which is in the 1950s. So what is our vision now of the future of AI? Well, some of it, think of it as conscious machines, like the movie Her. Some of it, see it as a fully autonomous society. Basically, machines do everything and we just get to relax and go to the beach. The other one is the ability to kind of use AI to extend human life, and the inevitable robot rebellion that will start with Siri. So this is the SAS definition. So we see AI as the science of training systems to emulate human tasks through learning and automation. So this is the core of the SAS platform when we talk about AI. So we run a survey to see what companies are thinking, because between the different definitions, there's a lot of confusion around what is AI. Is AI just machine learning? Is it just machine learning plus other stuff? Is it a crystal ball? What is it? So we asked companies at the SAS Global Forum in the US, what sort of AI application are you using or you want to use? So we see that most people, when they hear AI, they align it with machine learning, deep learning. There are specific applications such as computer vision or image analysis. And you see that a lot of them just don't pinpoint anything and just say, I don't know, or other, or something like that. So we tried to kind of drill down a little bit into it. So we see a lot of terms into the AI space. You hear chatbots, natural language processing, you see deep learning, self-learning. So we try to kind of arrange that into 2 subcategories. You have applications, AI applications. These are the end goal. These are the results. This is what you use AI to produce, or what you use AI to improve. You can have a chatbot without any AI into it, but you can infuse it. You can add little natural language generation, so all the responses aren't just written. You can take a Q&A system, an FAQ page, and turn it into a chatbot where the questions are more interactive, it feels more human. But to do that, you're going to need some capabilities. You're going to need some tools that can allow you to do that, and these are machine learning, deep learning, self-learning, all of these elements. These are the building blocks so you can reach the applications. Different combinations of these will give you different applications. So now that we have that definition set up the way we see it and the way we built our platform around it, I want to go to what does an open ecosystem mean. So an open ecosystem implies that there is a closed ecosystem. So I want to start every element of this ecosystem by looking how it used to be closed and how we are considering to leave it open. So when we talk about open ecosystems in AI or analytics, we're talking about being open to other tools. So in the past, you had a lot of proprietary tools. And this is still the case in the medical industry, for example, where they don't release the packages that they developed. Now you have a lot of languages. So you have Python, R. Everybody who learns data science has at least touched one of these languages, if not all of them, and they know how to develop models in that. So here at SAS, we used to be a closed ecosystem. We used to have, you needed to learn the SAS programming language to be able to access the SAS platform. Now we've opened it to Python, R, Lua, so you can actually access the engine behind it, all of the platform features without having to learn another language. The other thing is now we have more AI players in the market. So there's niche players, there's startups, there are different big companies doing different things, and so there are more choices, and that's good for everyone. More choices means you have to be open to different types of people. Not every organization is going to have a 500-person data scientist team. Some of them will have just one data scientist. They will not have a data engineer. They will not have a DevOps guy. So how do you help these companies kind of keep going with AI? So we need to democratize analytics, meaning if you have someone who has the business knowledge, a financial expert, a geneticist, and they want to do some analytics, or they want to build an AI application based on their genome analysis, they don't know how to write the algorithms, but you need to enable them. And this is when we design our platform, it was designed with a drag and drop interface that kind of explained for people who don't know how to code, but it's still open to the old school SAS coders. They can just use the tools they're used to, and then it's also open to the new generation of programmers. They can use open source. So open tools and open to different people come hand in hand because different people use different tools. And what this helps is in scalability. Because if you have one expert, you cannot scale your projects. Everything has to go through them, and they can't do everything at once. If you spread it out, you will gain more efficiency, more scalability in your projects, and then you will go more forward. But when you open your platform to more people, you need to govern it, because otherwise someone can just mess up your production environment. So you need to control what can do, who can do what, and where and when. The next thing I want to talk about is open data. Data is going through this curve thing, where it used to be nobody cared about it everywhere. Now everyone was centralizing their data. Now we're going back to data being open, but more in a shared environment. So companies used to have different databases, legacy databases. Now they're investing in more expensive distributed systems. And so we need to be able, in an open platform, to connect to any sort of data source and be able to process it the same way, whether it's a CSV file, a JSON, a PDF, a website, or Teradata, Hadoop, whatever it is. So an open platform needs to be open to different data sources. The next thing is algorithms. It used to be that you need to be really sophisticated programmer, C++ programmer, to be able to do multi-threading on an algorithm. Now there are libraries that do this off the bat for you. You don't have to be an expert in low-level programming. You don't have to know intensive mathematics to approximate things. These are done for you. So an open platform needs to be able to accommodate the new algorithms that are rising in different areas of AI, whether it's image processing or text analytics, but needs to keep that governance. It needs to make sure that anything you develop is embeddable, because what we're trying to eliminate is rewriting code. So if you build a platform, there has to be space for automation. So yes, you can incorporate new algorithms, but it might take time because those algorithms need to fit into a workflow. They need to be automated. They need to be governed. The next thing I want to talk about is open touchpoints. So what I mean by touchpoints is where are we doing the analytics? So it used to be that you just do your analytics on a server and then you get the results back. But now we're doing edge analytics as well. Your phone has more power than the Apollo 13. So we do a lot of analytics on the phone. One of the projects that I will talk about later, they were doing face recognition of players in the camera itself using one of our tools to make it faster. So it doesn't have to go to a central system and then back. The more you get closer to the analytics, the more you can be granular, the more you can target better, and you can spread the load. And finally, we want to do analytics in stream. I want to do it while data is being streamed, instead of collecting it somewhere, putting it in rest, and then doing the analytics on it. So you need to be open to all different types of touch points. When you touch the data, how fast is it going, how different it is, all of those things. The next thing is open infrastructure. So some companies want to have an on-premise installation. They're a bank, they're a social security, they can't put their data on the cloud. They're a European company who doesn't trust Amazon because Amazon is American and there are different weird American laws. So what do you want to do? You need to be open to clouds, but then you have multiple cloud providers. So you need to be open to all that different ways of creating a platform, because that democratizes the access. Not everybody has the money to kind of have their own data center, and Amazon can be expensive if you want to do bigger things. So having an open ecosystem means you need to have an open platform that can be installed anywhere, from one laptop to a whole cluster, and can scale with it in all those big data terms that you're familiar with. So how do we achieve that? So at the core of the SAS platform, we have what we call the analytical lifecycle. Everything starts from data, and everything goes back to data. So you start from data, you understand it, discover it, do some analytics on it, and then deploy it. So we'll go one by one. And so basically, when we talk about data, we talk about access. I want to access whatever type of data I want to access. I want to be able to get that data. I want to be able to combine data. No data scientist ever has gotten data set and was perfect from the start. So that needs cleaning. You want to be able to clean it, but you want to be able to clean it the way you know how to clean it. And then finally, you need to govern it. Some companies handle sensitive data. Not everybody's allowed to see everything. I worked for a company that collected data for them and their competitors. And so only one department in that company was allowed to see the data. So we're talking about row-level isolation. So you had one table which 7 rows, only 3 people can see, and the rest you're not allowed to see, because it can give you a competitive advantage to see the market share of your competitor. So governance is really important, because you need to separate given access to everyone and given the right access. The next thing is the discovery phase. So when we talk about the discovery phase, we're talking about now that you have your data, now that you've done some things with it, you see some sort of a trend. You look at your data and you see a trend. You see, for example, that one of your customers that is a gold customer doesn't like to be contacted by emails. You see that in his reviews, he doesn't like to be contacted by emails. So now you want to explore, is this just a one-off, or do the majority of my gold customers do not want to be contacted by email? They want to be contacted by phone, for example. So you explore your data, you try to see, okay. Then you realize there is a pattern here. Gold customers like that personal touch. They want to be contacted by phone. So you dig deeper and see, can I forecast this, or can I predict this? Can I use machine learning to predict what a customer will do based on their status? Or can I do the other way around? Can I predict if that customer is going to be turned into a gold customer if I switched how I contact him? Then you want to optimize it. You may have figured out the best way to predict this, but it takes 5 hours to train for some reason, because you're using 70 different algorithms at the same time running on one machine. So you want to optimize it. When you optimize it, you also want to automate it. And when you want to automate it, you can govern it, because you can control what it's doing. Now, it doesn't matter how great this algorithm is, it needs to be put into production. So we're talking about deployment, everybody's favorite word. So deployment is, okay, my model is ready to be put in production. What does a model ready to put into production mean? It means that it went through a validation phase. It means that it is documented well. It means that we are sure that it's the champion. It means that we know when this model is going to decay. Model decay is a big problem, because most companies do not have that identical environment between their test environment, which is most of the time a laptop of one data scientist, to their production environment, which is probably uses a different database with different packages. So you need to make sure that your model stays persistent as it goes. And the second problem that a lot of companies face is they tend to have to rewrite a lot of code. Something as simple as different versions of Linux between their acceptance environment and their production environment means there is package collision between what you used and what you didn't use. And so you will have to rewrite the code. And then if someone who's not a data scientist rewrites the code to make it more active, a lot of that performance is lost. They might cut some corners, a lot of the performance is lost. So our approach is to embed. So when we write something, we write it in a way that can run anywhere. That way we control how the code is. So you develop your algorithm once and just pick where you want to publish it. And that's how we ensure it. We do the monitoring of the performance of the algorithm, of how it varies from one environment to the other, but we also monitor when it decays. And then we automate that. So you can set up some business rules and say, if my model starts doing this, kill it, retrain it, or retire it and pick another model. The next thing is, this is the analytical lifecycle, but with AI at the heart of it. So on the bottom, what you see is what we call AI applications. So forecasting and optimization, natural language processing, computer vision, machine learning, and deep learning. But these cannot lead to an AI application if they don't have assistance, if you don't have the appropriate data management, if you don't have visualization tools, if you don't have deployment and decision support, you will not be able to take that and make it into a full-fledged application. So let's look at some of the applications that were developed using the SAS platform. So since I'm based in the Netherlands, SAS Sports is a case that I'm very familiar with. And today is the Champions League, so that's good. So SAS Sports, basically, they're trying to change how analytics on sports is happening. And normally, when they do the analytics, I don't know if you watch football, but you see how many passes, how fast the player is running. Most companies do that using sensors or actual humans. So there are actual humans just like touching on an arrow every time a player passes the ball. And so SAS Sports, what they're using is they're using 14 cameras, and they're isolating every player, and they're mapping their movement in 3D. And they were able to use SAS to embed that technology into the camera itself. So the camera will detect that this player has done this and pass it to their control center. The Wild Track Data for Good, this is our initiative to kind of use data for good. We are trying to help cheetahs by talking to tribesmen and then trying to codify their technique of tracking cheetahs. Cheetahs are some of those animals that don't like to be watched or tagged. They change their behavior. So what the scientists were doing, they would go to wildlife trackers. These are tribesmen in Africa, and they're able to detect when a cheetah is, where it's going based on its paw. So we kind of try to put that into a program by analyzing what patterns they look for and using image processing to cover that. Let's talk about one of the cases that I worked on in the Cancer Center in Amsterdam. So we use thousands of images, and I will try to put which tools are used from which life cycle. So we use thousands of images to kind of identify the anomalies. Then we introduce more data into there. So we introduce the family history of the person, the lifestyle, the diet, any sort of data that we can. Previous medical records. We try to look at health style, where they traveled, almost any sort of data we can collect on this person. And then we realized there is an ethical dilemma if a system says something, so we went the recommendation approach. We recommend the course of action to the doctor so that they can decide. Cancer cells look not smooth, so they look jagged, and regular ones look smooth. So that's one way of identifying them, but sometimes other factors come into how fast it is going to grow. Is it going to grow? Is it going to spread? Will it be killed? Will they survive the operation or not? And so we were trying to kind of give recommendations based on everything around the patient and not just the image, not just the scan, but kind of try to have a holistic approach to it. So the result is the clinic has a competitive edge. They don't have to look at images hundreds and hundreds of times. They just have to verify the ones the algorithm doesn't know how to tag. They just have to look at few samples. On the other hand, the physician has more time to study the case and gets more information about the patient. And finally, you have a better outcome for the patient because then you have a doctor who's more informed, and ultimately the decision is theirs. And making a decision based on something that was, infused with AI, it's helpful, but at the end of the day, ethically speaking, a doctor should always make the last decision. This is a claims case. So basically, this is a identifying damage through image processing. So image processing is a pain because, if somebody just steps back, the whole image changes. If they forget their finger on the flash, it's going to change the light. Filter, colors, there's so many things that could go wrong with imaging. So in this case, we were working on trying to identify how bad a crack is just by taking a picture from the cell phone. And so this is a process we were using. So we convert to grayscale because we don't really care about the colors of the car. We reduce the noise, we try to isolate the cracks. But another thing that stems from this project is fraud, because somebody can just submit the same picture 4 or 5 times from 6 different accounts. So whenever we identify the crack, we need to kind of understand what makes that crack unique to be able to identify if someone is trying to commit fraud. And finally, ATM forecasting. Understanding when you should refill an ATM, how many bills you should put in there, how do you automate your trip around the ATMs, because it's usually not the bank that does this, it's different companies that do that. And we relied on RNNs in this case to be able to predict when an ATM should be filled or when a particular bill should needs to be added. So for example, the 50 or the 20, depending on the area, depending on the demographic of the people living there. Younger people will use smaller bills, for example, than older people, and all of that. So thank you, and if you have any questions.
Thank you, Dan.
All right.
So we received 2 questions from the audience.
Okay.
Question number 1, what are the most used AI services by companies, and a comment on why do you think those are the ones?
The most used ones are, you mean from SAS or like in AI? Who asked the question? Can you pass the mic to him or something?
Just please wait for the microphone because we're recording. Thank you.
Is it okay? Yeah. Okay, thanks. So I think in general in AI, so like where do you see the possibilities to grow as someone who wants to expand their service portfolios?
So in terms of what I would recommend to anyone who's starting with AI, I would recommend text analytics. The reason why is because the text cases are standard. So any company will get complaints. So do complaints analysis, improve your user experience. So if I recommend someone to start with AI, start with text. It's well documented. Almost most companies have English into their portfolio. So it's helpful to understand the challenges, what you need to do with text. Text is very challenging, but text has a lot of different sources. So with text, you don't even need to have a data. You can just subscribe to an SMP service media provider and then get data on where your customers are going and what they're saying about you somewhere else. So the fuel of it is data, and text is the one that is the most abundant. You can even just start by scanning your own document and go for that. So in the last few months, I worked on 6 projects that are exactly the same. Big companies, they have IP data, so they have manuals, regulations, everything, and they want to turn that into a Q&A system. They don't want their engineers to go and look into the documents about how to fix a particular machine or how to perform a particular process. They wanted to ask the system, hey, how can I fix X, Y, and Z? And the system will give them that. And these were 5 different companies working 5 different industries with 5 different languages. I only speak 3 of them, so it doesn't help that that's the biggest problem with languages. It's different. And then as soon as you move towards languages that don't use Latin letters, you come up with another problem, which is, so Greek people, they use Greeklish, which is Greek with English letters. So how do you build a model for that? Because that breaks the language. Or I know people in North Africa mix English and mix Arabic and French and then sprinkle some English in there, and they put that in an official review. So it's easier for Americans and English people because, you know, that's what they speak. But for the rest of us, we need to figure out a way to deal with languages. So text is the best way to start, but as soon as you get more involved into it, you will face a lot of big problems. What's the second question?
We have another question, and you have the time. We're a bit ahead of a schedule, so feel free to elaborate
I like questions
even further.
more than reading slides.
So the second question is, GDPR with the open data, how to? Can we legally anonymize data? What is your point of view in this?
GDPR is a pain. When we talk about GDPR, so luckily the engineers in SAS have developed it into the platform itself, so we kind of are safe from that. I think GDPR becomes more, so let's use a real life example. I worked with a financial institution that wanted to you can fix your account by texting, right? And then one of the questions I asked was, okay, so somebody gives you your account number, and then he goes to sleep, or he goes out. So his account, which is an information protected under the law, is sitting there in the chatbot. Now, what if that company doesn't own the chatbot? Who keeps that data? Who's under the law liable that this person has put his account number and he just forgot to close the chat? So GDPR, the problem with it is that you need to make sure that you have, you know where your data is going, and at any point, at any stage, you need to be able to fix that. So if somebody gives you information that is private, you need to make sure that it's not only anonymous, but untraceable. You can't reverse it, because you can anonymize something and reverse it. You can anonymize something, but then you can just be able to guess the person if you combine 3 or 4 things that aren't anonymous. So you need to be able to not only anonymize the data, but make sure that it's not reversible if that person chooses to kind of delete themselves. So, and this becomes more complicated if you're working with a partner on something. So if you hire someone to do something for you, they need to adhere to your standards as well. Otherwise, it doesn't work well.
We have another question.
That's good.
SAS is more and more replaced by open source challenger like Python or Scala. What are, for you, the upsides of SAS in comparison with these?
Let's talk about SciSport, for example. They wanted to build this tool with open source first, and they built really good algorithms, but they couldn't put it in production because, for example, SAS has our engine called ESP. You can deploy your in-stream analytics even into a router or into a camera or into an engine, and you can still govern it and control the versions. So when we go into extremely complicated, I don't see it as like SAS versus open source, because I think it doesn't make sense, because open source is a language in a sense, and then SAS is an enterprise platform. So if a company wants to do it on their own, I mean, we don't know their business better than them. But what we do know is how to make things production and how to make it operational. And that's where I see companies, most of them try open source. And what I say is it's good that you tried open source because, you know, we have a head start. We can incorporate that into our platform. We've added the ability that you can operationalize open source models. So we can, you know, work with that. The idea is, I don't like the word versus. I see that a lot. I'm like, you know, I use open source more than SAS when I build my product because I'm working within, I like to use that language, but I'm using the platform itself. And this is the message that we're sending, is that we used to be really closed SAS, and now it's more open. We understand that more people now know open source, and it's a good thing because we have more data scientists, more data engineers, which makes more companies want to buy our stuff.
Thank you very much.
Yeah?
If we have no more questions
Any
from
more
the
questions?
audience? No, I don't see any on the platform. Thank you very much.
Of course. Yeah.
And before you leave, I would also like to give you this certificate.
Oh, certificate for what? Being
awesome. For having a contribution for the Data Science Conference. Thank you very much, Dan. It was a very great experience.
Hey, thanks. Thank you.
Since we are running a bit ahead of schedule, we will reconvene in 10 minutes. So